Friends, welcome to Unacademy. How are you? So I hope your preparation is going absolutely fine, and you are preparing for upcoming GATE exam with full josh, right? And we were discussing about the fluid static, and it is the last portion of fluid static. Basically, only two things are remaining in fluid static. One is stability criteria, right? What is the stability criteria for floating body? That is metacentric height and all that is remaining basically. And other than this, fluid in relative equilibrium is remaining. In that also two problems are only there. One truck is there that is moving, so water will be tilted, and in that condition it will be treated as a stationary. So that is one problem, and another problem is one container is there, in that water is there, that container is going to be rotated, right? So these two problems are only remaining. So basically I can say in fluid static portion three things are remaining, beta. Three things are remaining. The very first thing that will complete today itself, that is metacentric height. Questions based on metacentric height. The second thing that is remaining is if a body of a container of water or container of a fluid is accelerating in a linear direction. So that is the second type of problem. And third type problem, one container that is filled with a fluid and that is going to be rotated with a constant omega, basically you can say. So that is that three things basically we need to discuss here. That's it, and then this topic is going to be finished. Now after that, how you can get the good marks? Very simple thing. Whatever I teach up to now, that is more than sufficient to get full marks on fluid static. No need to refer any other content or let's say books or something, not required. Only what is required, you need to solve more and more problems. You need to solve more and more problems. Sir, from where I can solve the problem? Very easy, right? Very easy. You can solve the problem from various test series. Even Unacademy is providing very good test series, and even there are question banks in Unacademy, so you can solve those problems, and some of the question bank practice sets are free of cost, so you can attempt those questions. That is one way. Another one is that you can solve the problems from K. Subramanya book. That is really very good book as numerical problem is concerned, right? Theory part maybe not that much sufficient, but numerical point of view, it is one of the good book, I would say. Means out of 10 problems, 7 to 8 problems are relevant for upcoming exams like competitive exams. So that is really a very good ratio, I would say. So this is about the problem solving. Then after that, what I am going to do, like today and tomorrow. So tomorrow basically fluid static is going to be over. Then after that I will start fluid kinematics, then fluid dynamics, then laminar flow, pipe flow, momentum equation. In between we will discuss, and then boundary layer theory, turbulent flow, correct? And these things we will try to cover. So basically like 70% portion of fluid mechanics I am going to cover by this 15th itself, right? I will try to complete 70% of portion in this 15th, but this 70% portion which I am going to cover for coming 15th up to 15th, believe me my dear friends, this is the only portion from which majority of question will come. See, even up to 15 I am talking about, up to 15th, right? Up to 15th, coming 15th, I am going to cover approximately 70% of the syllabus, right? But from this 70% syllabus, 90% problems will come. And whatever 30% syllabus is remaining, that I will cover basically. Don't worry, that I will cover. Don't worry, right? But from this you will get only 10% questions. So basically, whatever basic part is there, right? Like fluid static, kinematic, dynamic, pipe flow, laminar flow, boundary layer, dimension. So this part, majority questions are coming. Some other topic like dragon lift, turbulent flow. And even some more topics are there in boundary layer theory and this dimensional analysis. Also only few portions are there which is actually relevant and important for upcoming exams, right? For competitive exams basically. So even though I am going to teach everything, every complete 100% syllabus is going to cover, right? But whatever I am going to cover up to 15, from that 90% question will come. So what I am trying to say, that you need to practice these questions, frequently. You have to practice this particular portion frequently, then only you can get very good marks. Even many of you are writing the this GATE exam through XC, and in XC they may choose fluid mechanics as a one optional subject. So for them I suggest you to solve previous year XC problem also. Previous year XC problems, and XC problems are somewhat good quality problem. Even I can say, if you compare with the mechanical or chemical or this one civil, then the level of question is little bit high. So for that, you just solve previous year question. You can solve case Subramanya problems, right? Even ESE conventional also you can solve. See, for GATE point of view, ESE prelims may not help you that much, but ESE conventional will definitely help you, especially when XC is going to be concerned, right? So this is the thing. So I hope you have understand the logic behind this. And let me start with my introduction, my beta. So myself, Shivam Dixit, even most of you may know, right? Because already 15-16 lectures are already over. So most of the students may know about me, but still I'm going to tell you that I'm Shivam Dixit. I did my MTech from NIT Calicut in thermal and fluid. And after that, I got selected in many PSUs, including IOCL R&D as Automotive Research Officer. And from last 9 years, I am guiding the GATE and ESE aspirants. Even many of my students secure single digit and double digit rank. You can go and check in YouTube. There are a lot of testimonial videos where students said that I'm beautiful, right? I'm good actually, right? So you can see that, right? Actually, before coming to this profession, I thought of going as a hero. Okay, ho gaya. Everything is fine. So shall we start, beta? Shall we start? Yes, correct. Okay, Science. Sir, how to prepare for campus interview mechanical? Okay, I'll tell you, beta. I'll tell you. XC in FM and TD, what branch are available in IIT through these two subjects? You can go for thermal also, even design also you may go, and most of the branches are applicable, beta. Most of the branches are, whatever interdisciplinary branches are there, that is also applicable. So most of the branches are applicable, but detail if you want to know, then I have one PDF, right? I have one PDF where all the cutoffs, everything is mentioned. So you can ask for that. I'll definitely give you. Okay. Clear as? Shall we start? Shall we start, beta? Okay. Now please listen here carefully. Okay. Thank you. Stop messaging. Please listen here. That we were discussing about the stability of the bodies, right? Stability of bodies, I told that there are three type of stability or three type of equilibriums, I can say, right? Three type of equilibriums basically, right? Just I want to recall all these concepts, whatever I discussed in previous video, just in 5 minutes. So first one is stable equilibrium, means this is basically stable equilibrium, right? Stable equilibrium. Now you can see that if you pull, right, please listen here, if you pull or if you just change the position of this this ball, then after some time it will again try to regain its original position, and it will gain their original position, because once you are moving from their initial position, this is the initial position, this is the final position. So whenever we are moving from one state to two state, then automatically we don't need not to do anything. Automatically one force will start acting in this direction due to the gravity. Due to the gravity is doing this. I am not doing anything. So it will come to their original position. This is a stable equilibrium. Now second diagram, you can see that here it is a unstable equilibrium. Unstable equilibrium. unstable equilibrium. Now in unstable equilibrium, you can see that even if you touch it little bit also, then it will move, right? It will move basically. This is the initial condition, right? Now here one more thing I am telling you, you just touch it. When you touch it in one particular any other direction, either this side or this side, so once you will touch it, then what will happen? In the same direction, one couple will form. In the same direction, one force will start acting because of gravity. So that's why what will happen? It is an unstable equilibrium. Correct. Now in first case, second case, what is happening that in both the case one force will start acting due to gravity, but in first case it is opposite to the momentum. Whatever movement you are doing from one to do, so whatever force will start acting, that is opposite direction. But in second case, basically it is in the same direction. It is happening in the same direction. Clear hai? That is unstable equilibrium. Then third one is neutral equilibrium. Neutral equilibrium means suppose it is a flat surface and here some ball is there. Now if you push this ball from state 1 to state 2, then it will be here only. It will reach the state 2. Right, but there will be no any effect of gravity, right? Because of gravity, nothing is going to change, because no any force or couple is going to be produced. So this is basically what neutral equilibrium. Clear hai? Okay. Then first we were talking about stability condition of submerged body. Like we are submerged bodies. We are submerged in air. Or suppose one balloon is there. So that balloon is submerged in air. Submarines are there, right? Submarines are basically submerged in a sea. So basically, what is the stability criteria for stable equilibrium? So for that, it's very easy. Center of gravity must be below the center of buoyancy. See, suppose any body I am taking, right? This is the arbitrary shape I am taking, right? Now, if suppose density is not everywhere same, means here somewhat more weight is there. Here let's say more weight is there. If here weight is more, please listen here carefully. Please listen here carefully. क्या बोल रहे तुम लोग? Yes. Clear है? Just a minute, beta. Okay, so now please listen here carefully that. 8 minutes. Okay, now it's fine. So now you can see that here at this point, like, see, if there is density is equal in everywhere. If density is equal everywhere, then what will happen, beta? Then center of gravity will come somewhere here. But center of gravity is moved basically. Now center of gravity is here G. So weight is going to be act at this particular point. Weight is going to act in this particular direction, right? Now buoyancy is going to act on the center of gravity of the you can say the displaced fluid. So for that it will come somewhere here. So B will be something like this. Now this is a stable condition, sir. How can you say that it's a stable condition? If you move it in this direction, if you do move in this direction, then what will happen? In any direction you can tilt. If you tilt in this particular direction, right? If you tilt in this particular direction, then what will happen basically? Please listen here carefully. What will basically happen? So now you can see that. Please listen here carefully. Please listen here carefully. So this is weight W, and this is buoyancy force B. So we are tilting it in this direction, and automatically one couple. See, ये couple देखो ये कैसे ऐसे लग रहा है, right? We are tilting in this direction, but a couple is going to act in this particular direction. Clear है ना? So basically this is what stable equilibrium. Stable equilibrium. So always remember, beta. Always remember that if a submerged body is there, right, and in that submerged body center of gravity is below the center of buoyancy. Center of gravity is below the center of buoyancy, then it will be stable equilibrium. Stable equilibrium, right? And if center of gravity is above the center of buoyancy, if center of gravity is above the center of buoyancy, then it will be unstable equilibrium. And if both are going to be coincide, then it is a neutral equilibrium. So these things we already discussed, so that's why I am not discussing it again. I'm not discussing it again. Clear है बेटा? Wait. कहाँ चले गए भाई? क्या पूछ रहे? एक मिनट. Just a minute. Okay. Now the next point, beta. Next point is in here. Stability condition for floating body. This is actually the important thing for us. So basically we are going to talk about the stability condition for the floating body. Floating body की बात करेंगे. Now if a body is floating, then I already told you, again I am explaining because this is basically today's topic. This is basically today's topic. Now I am going to draw one body which is floating, and it is somewhat big body I am going to draw. Right. Now in this body, please listen here carefully. Please listen here carefully. Right. Where is going to be the center of gravity? Let's say assume that individual density is same. I am assuming that individual density is same. So what will happen, beta? This is, let's say, D. So center of gravity will come at D by 2. Center of gravity will come at D by 2. So D by 2 will be somewhere here, right? This is basically what D by 2. D by 2. Clear hai? Now how much portion is submerged? How much portion is submerged, beta? This H is basically submerged. Let's say H is submerged, right? So what is the center of gravity for the displaced fluid? So displaced fluid is what part? I'm going to draw with green color. Let's say this is the displaced part. This is the displaced part. अरे देखो भैया इधर देखो. This is a displaced part, beta, right? Now it will act at the center of this displaced part, means H by 2. So it will act somewhere here, right? So this is going to act at H by 2. Clear hai? H by 2. Now please listen here carefully. So it is a center of gravity, so it will act downward direction, weight will act here, and this is going to act upward, W, FB I am writing. Now please listen here carefully. Please, this is very very important बेटा. अगर ये नहीं समझे तो बस लाइफ खत्म है, right? फिर कोई मतलब नहीं एग्जाम देने का, right? Then there is no meaning of writing a GATE exam. Now I am going to tilt in this particular direction. I am going to tilt in this particular direction. If I tilt in this particular direction, then how the body will be look like? Let's say. Clear है बेटा? Clear है? Now in this case, if when you are tilting beta, when you are tilting in this direction, is there any change in the location of center of gravity? G will not change beta. G will obviously will not change, right? So G will be in their position, means center of this one, I can say somewhere here, right? This is a G basically, right? This is basically G. So G will act here, something like this. Now but B will definitely change beta. Earlier B was where? Earlier B was in somewhere here, let's say, right? B was here. Now because the shape of displaced fluid is changed, so now it will not act in this particular axis, it will change. Let's say it is changing to the this direction, right? Let's say, okay, this direction I'm saying that. This is B. This is B and this is B dash. B dash is a new position of center of buoyancy. What is B? B is the initial position of center of buoyancy. Right now B dash is the new position. So now it will going to act like this. Now it will going to act like this. FB will act like this, right? So if you extend this line, please listen here. अरे इधर देखो भैया, इधर नहीं देख रहे तुम लोग, क्या कर रहे हैं मुझे समझ में नहीं आ रहा. Now this point is called as what? Metacenter. This point is called as what? This is basically what? Metacenter. So now you can see that metacenter is above. Metacenter is above the center of gravity, above the center of gravity. Now please listen here carefully and tell me, it is a stable equilibrium or unstable? Sir, it is a stable equilibrium. Means, see, we are tilting in this direction, we are tilting in this direction, automatically one couple is generated in opposite direction, one couple is generated in opposite direction. So basically this is a stable condition, stable equilibrium or condition, stable condition for floating body. It is a stable condition for floating body. If someone will ask you what is a stable condition for floating body, then you have to say that metacenter is above the center of gravity. Metacenter is above the center of gravity. If metacenter is below the center of gravity, then it is unstable equilibrium. If both are going to be coincide, then it is a neutral equilibrium. Up to now, if anyone have any problem, tell me. Clear है जावेद शेख? Clear है? Shall I move forward? Shall I move further? Now please, so this is basically metacentric height. Now I am saying that the distance between the center of gravity and metacenter, the center, right? The distance between the center of gravity and metacenter is basically known as metacentric height. This is basically known as metacentric height. Now, for stable equilibrium, metacentric height is positive. See, whenever we are measuring from G to M, so upward direction is positive. Upward direction is positive, right? We are considering, like, suppose this is the, let's say this is the axis, right? This is the axis, right? Now in this axis, somewhere G is acting here. Initial B is somewhere here. Initial B is somewhere here. Now it is shifted somewhere else, right? B dash, where it will say, I don't know. And finally metacenter is somewhere here. Metacenter is somewhere here. Metacenter is somewhere here, right? If metacenter is here, so metacenter is above the center of gravity, then we will say that it is a stable condition. Please listen here carefully. Stable condition or stable equilibrium. Stable condition or stable equilibrium. Listen here, chapa. Now this height is called as metacentric height. Metacentric height. Right, now it is measured from G to M, and whenever we are moving from G to M in upward direction, then it's all called positive. So this is what? Positive metacentric height. This is called as what? Positive metacentric height. Let's come to the next one, that is unstable equilibrium, right? Unstable equilibrium. So unstable equilibrium means, let's say G is here, right, and B is somewhere here, and B dash is somewhere here, and metacenter is coming somewhere here. Now this is also metacentric height only, but negative metacentric height, right? This is the metacentric height negative. Now this is the unstable equilibrium. Unstable equilibrium. Right? Unstable equilibrium or unstable condition. Clear है? किसी को कोई confusion? Anyone have any confusion? No confusion at all. Now one more thing I would like to tell you here, for like, if you want to ask me for neutral equilibrium, so for neutral equilibrium both will coincide, basically both will coincide. I'm drawing small diagram here. So basically here what will happen? This is G, and this is M only, this is the M only, this is B, and somewhere here B dash. Now this is a neutral equilibrium. Neutral equilibrium, and metacentric height is 0. Metacentric height is 0. Clear है? Metacentric height is coming 0 here. Metacentric height is coming 0 if it is a neutral equilibrium. Clear है? Confusion? No confusion. But sir, from where question will come? Question will basically come from this particular thing. Then right, how to calculate the metacentric height. Now you need to understand one more thing, that suppose two boats are there, right? For one metacentric height is positive, second also metacentric height is positive, means both are what? Both are stable. Both are stable. But for first one metacentric height is more. For first one metacentric height is more, second one metacentric height is less. So in that case, what will happen, beta? What will happen? Can you tell me? That if positive metacentric height is more, right? Metacentric height is more, then it is a more stable condition. Means suppose two boats are there. One is your boat, one is your friend boat. Now your friend boat metacentric height is very huge. He designed in such a way that metacentric height should be more. Now you design that, okay, it should be just positive metacentric height, that's it, it will be stable equilibrium. Now you both are going in a sea or river. Suddenly some storm is coming or something is coming, then what will happen? Then you are stable but in certain conditions, right? But your metacentric height is less, so kya ho jab palat jate? But your friend will be in stable equilibrium in that condition also. So what I am trying to say, the metacentric height is as high as, like if it is more, then it is a more what you can say, more stable condition. Clear? That is a more stable condition. Now we will see the mathematical condition for only and only we are discussing about the stable equilibrium. Only stable equilibrium I am going to talk about here. So for stable equilibrium, what I can say, that for stable equilibrium I can say, let's say this is B basically, right? This is B, this is G, and this is M, right? And this is the, we have to find out GM value. We have to find out GM. So this is a positive metacentric height. This is a positive metacentric height. So this is a stable equilibrium. I can say stable equilibrium, right? It is a stable equilibrium. Stable equilibrium means what? Stable equilibrium means what? That BM is greater than BG. BM is greater than BG. Right, BM is basically greater than BG. If BM is less than BG, if BM is less than BG, then we will say it is unstable equilibrium. उस केस में क्या हो जाएगा? मेटासेंटर जो है वो सेंटर ऑफ ग्रेविटी और सेंटर ऑफ बॉयंसी के बीच में आ जाएगा. Now whenever you want to calculate the value of metacentric height, if you want to calculate the metacentric height, then what you have to do? You have to BM value we can find out, BM value we can find out, BG value we can find out. So basically I can write here, formula is GM we have to find out. GM is equal to BM minus BG. BM minus BG. Please listen here carefully. This formula we have to use. Sir, why we are not directly calculating GM? Why we are not directly calculating GM? Because it's very easy to calculate BG. BG is very simple. Just locate center of gravity of the body, then locate the center of gravity of the displaced fluid, right? So BG value you can calculate easily. BG value you can calculate easily. Even to calculate BM value, we have one formula. That derivation is also there, but that derivation I am not going to give you. Directly formula I am going to give you because it's a short term course, otherwise course will not complete on time, right? So basically I am going to give you the direct formula to calculate BM value. Once you will get BM value, once you will get BG value, and BG is very easy to calculate, then we can find out very easily. Let's say one block is there which is floating, right? This is a okay, I'll draw one block, right? This is one, maybe you can say it is okay, rectangular block I am taking, right? Clear है? So this is, let's say, rectangular block, right? Rectangular block. Now it is floating. So this is the water surface or fluid surface basically. Right? This is a right? This is, let's say, length is L, for example. L, right? This is L basically, and this you can say it is a B. Small b better I'm writing. This is, let's say, D. Clear, eh? So this is B, this is D, right? Now please listen here carefully. Now please listen here carefully that G value will come where basically? G value, obviously G value is going to come at D by 2. So this is basically G, and this value is going to be like D by 2. Or from top also you can measure, that will be easy basically. This is D by 2. Clear hai? That is G value. G value we can easily locate. Now suppose it is submerged H height. H height is submerged. That H height also we can find out. The value of this H, either it will be given to you, either it will be H value will be given to you. If it is not given, beta, if it is not given, then we can find out with the help of principle of flotation or Archimedes principle, right? Principle of flotation se H value nikal aayegi, right? We'll solve one problem, then we'll understand. Now then H by 2, right? So this will be somewhere here, for example, right? This is H by 2. This is H by 2. Clear, right? So now this is B. This is a B value, right? So BG value is very, very easy. BG value will come how much? BG value will come D by 2 minus H by 2. D by 2 minus H by 2. This is the case I am taking rectangular block or something, right? If the shape will change, then obviously these values will also change, correct? And that will depend upon the shape basically, right? Up to here any confusion? Tell me. Up to here any confusion? Tell me. Now we have to calculate BM value, right? To calculate BM value, before calculating BM value, few more things I would like to tell you here. The very first thing I am telling you that here whatever cross section top is there, whatever top portion is there from here, this can be classic. This can be say that longitudinal axis. This is basically L I am writing. I am writing L. It is basically what longitudinal axis, right? It is a longitudinal axis, and this is basically transverse axis, T comma T. So if I draw here, I have to draw the same thing here to make you understand. If I am drawing here something like this, right? Now this is what longitudinal axis L, and this is transverse axis T. Now whatever boat you have, right? Whatever boat or whatever block you have, it may be move like this also. It may move like this also, or it may move like this also. Correct. Now, if it is moving or moving around this longitudinal axis, that is called a rolling. Now this part, if it is about longitudinal axis, that is called as rolling, right? It is called as what? Rolling. Clear? And if it is moving around the transverse axis, that is called as pitching. That is called as what? Pitching. Sir, why you are saying all this one? We just calculate the value of BM, na? That's it. No, actually here you need to understand that if I calculate the moment of inertia, right? If I calculate the moment of inertia I, right? If I calculate the I value, to calculate I value, you need to know whether you are calculating this value around longitudinal axis or transverse axis, right? For example, this value is, let's say, L, this value is B, right? Same I took now. Now if I find out the moment of inertia I towards longitudinal axis के around निकालेंगे तो क्या हो जाएगा, right? It will come B, it will come LBQ by 12. If I calculate I value towards transverse axis, then it will come BLQ by 12. Now here you can see that L value is basically more. If L value more, then BLQ by 12 will be more than LBQ by 12, right? So basically I can say that moment of inertia of transverse axis is greater than IL. Clear hai? This condition is actually required. Just wait for some time, it will be required. Now forget about all this. Now I am going to tell you that what is how to calculate the value of BM, right? Because BG is already calculated. BG is very simple to calculate. So BG is already calculated. Now I am going to calculate BM. So BM is basically I by V, right? I by V. Please listen here carefully. What I am saying that BM is equals to I by V. I is moment of inertia and V is what? V is the volume of the fluid displaced. V is what? That is volume of the fluid displaced. Clear hai? Volume of the fluid displaced. Now BM value you can calculate either in transverse axis towards because I is defined for what? I have two values na. Either around TT or you can say LL. So if I calculate BM in transverse axis, right? So it will come how much? IT by V. Now BM for longitudinal axis, then it will come IL by V. Clear? Now just now we seen that IT value is more. So BM value, BM of transverse axis is actually greater than BM as longitudinal axis. This point is clear? Anyone have any confusion, you just let me know. In this point you need to know, otherwise you will do the mistake in solving the problem. Clear hai? BM of transverse axis is greater than BM of longitudinal axis. Now if you want to calculate GM value, right? If you are calculating BG is fixed for example, right? Now if you are calculating the value of GM, this point is very important. If you are calculating GM value, beta, right, then and if you are taking BM value in the transfer direction, TT, right, BMT, if you are taking BMT, then what will happen? Then basically this value, GM value will be more. GM means GM value, if you are calculating, one thing I am telling you, GM value in transverse direction, right? GM value in transverse direction is going to be greater than GM value of longitudinal direction. Please listen here carefully, okay? Now everyone understand this point clearly, because it is very important. See, if you want to find out metacentric height, then you can say that BM minus BG. How to calculate BG? BG is very simple. You just locate the G, the B and find out the BG value. Okay, fine, leave it. Now how to calculate BM value? BM is equal to I by V, but BM may have multiple values. Right? Let's say in this particular case, BM have two values basically around transverse axis and longitudinal axis. किसके around निकालना? That matters basically. But what you have to do, that is more important. Now you can see that if you are taking BM in transverse direction, then GM value will be more. If you are taking towards longitudinal direction, then this value is going to be less. Clear enough, beta? Now, what is GM? GM basically metacentric height. If metacentric height is more, means more stable. Means if you are going to design, your boat or your floating body, any floating body around or with respect to longitudinal axis, with respect to the IL, then it will be definitely be stable in a transverse direction. Please listen here, bhaiya. Please listen here again. What I am trying to say, beta, that if you are designing your boat for longitudinal axis, then obviously it will be equilibrium with the transverse axis. Why? Because longitudinal में तो GM का वैल्यू कम आता है ना, right? और उसके तो if suppose it is stable equilibrium with the longitudinal direction, so it means that in a transverse direction the value of GM will be more. GM will be more, it's more stable. It is basically what? It is basically more stable. Are you getting this point or not? So, for design point of view, we always consider least moment of inertia. And what is least moment of inertia? That is LB cube by 12. So, moment of inertia about the longitudinal axis you have to consider. Correct na? Longitudinal axis आपको consider करना पड़ेगा. If any body is stable equilibrium towards the longitudinal axis, then obviously it will be equilibrium with the transverse axis, right? So design किस पे करेंगे? So you have to design for longitudinal axis. Clear है? Any confusion? Let me know. So this is the note point that you need to write. You just first write down this part. Now you write this particular thing. For a design point of view, least moment of inertia means around longitudinal axis is taken into the consideration. Least moment of inertia means longitudinal axis is taken into the consideration. Clear hai? Okay, we will solve one problem on this. First we will solve one problem, then we'll see. First we will solve the problem. Please look at this problem. Everyone look at this problem and try to solve this. Yes, very good. If anyone have any confusion, yes, Mandal. Good evening, Mandal. Good evening, Mandal. Javed say good evening. Please try to solve this problem. Answer, if you say I can tell the answer also, I have answer with me. Answer I will tell you. I have answer with me, but I will tell you. First you solve by your own. First try to solve by your own, beta. A rectangular body a rectangular body 5 meter long, right? 5 meter long, so I will draw like this. It is a 5 meter long, 3 meter wide, 1.2 meter and 1.2 meter right. solid, fast. Whoever will give the answer first, he will get one chocolate. Is the chocolatey problem? It is the chocolatey problem. Solid, fast. Solid, fast बेटा. कितना दिया? 5 मीटर. Solid, fast. If nothing is mentioned, then you have to calculate I value. You have to take towards longitudinal axis. Always remember towards longitudinal axis. Now 1.2 meter. This is 0.8 meter. This is 0.8 meter. Now please listen here carefully. Please listen here carefully. Where is going to be G? G is going to be here. G value will be somewhere here. That is 0.6 meter, right? 0.6 meter. Obviously from here I measure 0.6 meter. 0.6 meter. Clear hai? Clear hai? And B is going to be somewhere here, mid of this one. So it will be basically at 0.4 meter. So what is the value of BG? BG value will be, BG value is 0.6 minus 0.4, that is 0.2 meter. 0.2 meter. Now you have to calculate BM value. Right, BM is equal to I by V. V is what? V is the volume of the fluid displaced. V is the volume of the fluid displaced, right? So now I am going to calculate BM value, right? BM is equal to, first should I calculate I value? Okay, I obviously on longitudinal axis, so I can say LB cube by 12. So L means 5 into 3 square cube by 12. So this value you calculate. Right, then you can write here BM value, right? BM value will come how much? First calculate volume displaced. Please calculate volume displaced. Volume displaced value will come how much beta? Volume displaced. So area into the depth. Area into depth. Area is what? 5 into 3 into 0.8. Correct answer. 5 into 3. This is the area, and how much area is submerged basically? How much area is submerged? 0.8. 0.8. So this is value. So I can say BM is equal to basically IL by VD. IL by VD. So you just calculate this value. So I think you will get 0.9375 meter. If I am not wrong, you will get this particular value. If I am not wrong, you will get this particular value. Now you have to calculate GM value. So I can say that GM is equal to, this is M for example. So GM is equal to BM minus BG. BM minus BG. So BM value is 0.9375 minus BG. BG is how much? BG is 0.2. So this value will come 0.7375 meter. Have you got the answer, beta? Have everyone got the answer? Have everyone got the answer? Have everyone got the answer, beta? Tell me. If you get the answer, please tell me. Yes. Good. Very good. 11.25. I value 11.25 आ रहा है क्या? Okay. That you can. GM value बोलो जावेद शेख. Javed Sheikh, what is GM value? Clear है? one more problem we will solve. Javed, we will solve one more problem, beta. Is it done? Is it done? अरे बोलो बाबू, बाबू सोना, दो प्रॉब्लम कर लो बहुत है. Now solve this particular problem. Everyone solve this particular problem. For a cylinder of density 600 kg per meter cube floats in an oil density of 900 kg per meter cube with the longitudinal axis as vertical. Longitudinal axis obviously vertically रहेगी longitudinal axis. ऐसे हम कभी देखा है क्या? ये जो डब्बा होता है, डब्बा कभी ऐसे फ्लोट करता है क्या? वो तो ऐसे ही फ्लोट करता है ना, क्योंकि वही स्टेबल कंडीशन है उसके लिए. Yes. If L is the height and D is the diameter of the cylinder, they show that for stable equilibrium, this is the condition. For stable condition, equilibrium, this is the condition. Please try to solve by your own. Please try to solve by your own. Please try to solve by your own. So it is something like this. ठीक है? It is, let's say, something like this. Right? Now this diameter is given D and this length is given L. Solve it fast. So G will obviously come at the center of this body. G will come at the center of this body. Let's say center is somewhere here. So this is basically G. So it will come at L by 2. It will come at L by 2. L by 2. G value. Now we have to locate B. We have to locate B. So this is, let's say, H. So it will come at H by 2. 2L by 3 of cylinder is inside oil. Very good. Very good, Javed. Very good, beta. So this value will come how much? H by 2. H by 2. But we have to find out the value of H basically. So for that, for floating body, principle of flotation. Principle of flotation is what? The weight of the body is equal to weight of the fluid displaced. Weight of the body is equal to weight of the body is equal to weight of the fluid displaced. Correct? Weight of body क्या हो जाएगा? What is weight of the body? Weight of the body में rho g into volume. Rho of body, g of body. Rho of body will be like 600 into g into volume of the body. What is volume of the body? Pi by 4 d square into L. Pi by 4 d square into L. This is the volume of the body. Is equal to. Now what is the density of oil? Oil 900 into G into the volume of the oil displaced. Oil कितना displaced हो रहा है? Oil displaced is pi by 4 d square into H. Pi by 4 d square into H. Now you see G cancel out. Pi by 4 can d square cancel out. So basically H value will get 6 by 9. 6 by 9 means 2 by 3. Correct है, एकदम सही निकाला शेख. जावेद शेख ने एकदम सही निकाला. सुंदरम, पुलकित, नरेश, IIT के लिए क्या? अरे पहले तुम क्वेश्चन सॉल्व कर लो. IIT के लिए क्या करना पहले बता दो. क्या लोग रहते यार. इधर क्वेश्चन चल रहा है हमको आईआईटी में क्या करना है, क्या नहीं करना, कैसे करना, ये सब पूछ रही। नाउ कैलकुलेट बीजी वैल्यू बेटा। बीजी वैल्यू विल कम हाउ मच? बीजी वैल्यू विल कम हाउ मच जावेद? BG value will come L by 2 minus H by 2. So L by 2 minus H by 2. So minus 2 by 6L ना, यही आ जाएगा ना, 2 by 6L I think so। देखो देखो कितना आ रहा है। इधर 6 LCM लेंगे तो 3 आ जाएगा, 3 minus 2 L by 6 आ जाएगा। ये देखो आ रहा बीजी वैल्यू L by 6। यस जावेद वेरी गुड, यस जावेद वेरी गुड बेटा। नाउ अभी BM निकालो, BM निकालो। BM क्या होता था? BM पहले मैं इधर लिखता हूँ, BM का फॉर्मूला इधर लिख रहा हूँ मैं। BM इज इक्वल टू I बाई वॉल्यूम ऑफ द फ्लूइड डिस्प्लेस्ड। I क्या होता है? I क्या होता है सिलेंडर के लिए? I वैल्यू हो जाएगा पाई बाई 64 D टू द पावर 4, राइट? यही होगा ना, D टू द पावर 4। वॉल्यूम ऑफ द फ्लूइड डिस्प्लेस कितना हो जाएगा? वॉल्यूम ऑफ द फ्लूइड डिस्प्लेस कितना हो जाएगा? दैट इज पाई बाई 4 D स्क्वायर इंटू H, पाई बाई 4 D स्क्वायर इंटू H, और H कितना है? 2 बाई 3 ऑफ L, करेक्ट है। नाउ ये वैल्यूज यहाँ पुट कर दो, तो BM इज इक्वल टू I बाई वॉल्यूम ऑफ द फ्लूइड डिस्प्लेस्ड करो जरा, इसका वैल्यू निकालो, BM का वैल्यू यहाँ पे निकालो बेटा। ये दोनों इक्वेशन मैंने लिख दिया तुम्हारे सामने। पाई बाई 64 है, सॉरी पाई बाई 64 है, पाई बाई 64 D टू द पावर 4, और वॉल्यूम ऑफ द फ्लूइड डिस्प्लेस हो गया पाई बाई 4 D स्क्वायर इंटू H। H का वैल्यू इज 2 by 3 टाइम्स ऑफ L। सॉल्व इट फास्ट। Yes, solve it fast। So I think it will come 3D square by 32 times of L। Is it correct? Check once, just check once। Right, now what I told you earlier, just look at here you can see that BM must be greater than BG. This is the condition for stable equilibrium. For stable equilibrium BM must be greater than BG, right? For stable equilibrium BM must be greater than BG. BM must be greater than BG, right? BM must be greater than BG. Yes, very good. Now BM value कितना आ रहा है बेटा? BM value कितना आ रहा है? अरे ये प्रॉब्लम कहाँ है? कुछ भी लिख रहा हूँ मैं, यहाँ पे लिखना, अगर परेशान हो गया। BM इज ग्रेटर देन BG। BM वैल्यू कितना है? 3D स्क्वायर बाय 32L इज ग्रेटर देन BG। BG कितना है? L by 6। So from here if you calculate L by D value, see तो नहीं आ रहा है L by 6 है में लग रहा है कि L स्क्वायर बाई हो जाएगा L स्क्वायर बाई D स्क्वायर विल बी लेस देन हो जाएगा 6 ऊपर चला जाएगा ना 6 इंटू 3 तो इसको 2 से बार डिवाइड कर देंगे सो 2 2 3 6 3 9 आ जाएगा ये और इसको जब 2 से करेंगे तो 16 आ जाएगा 9 by 16. So L by D value will come. So from here I can say L by D value must be less than 3. So this only we need to prove. This only we need to prove. Clear hai beta? Any confusion you can tell me. Any confusion if you have, you can let me know. बोलिए fast. Tell me fast. If anyone have any confusion up to here, just let me know. Just let me know. Clear है? सारे लोग सॉल्व करो जल्दी. Clear है? Now I am moving to the one more problem we'll do. We will solve one more problem beta. We will solve one more problem. आज मैं कमेंट नहीं पढ़ पा रहा हूँ actually. Right. Okay, now next problem. Okay, this is the last problem for today. Solve it fast. Solve it fast beta. Solve it fast. This is the last problem for today beta. Solve it fast. A solid cylinder at length L, density 600, float in natural equilibrium. Natural equilibrium with the longitudinal axis vertical in a water. Then find L by D. So let's say exactly similar problem beta. Exactly similar problem. Okay. Just now I will solve it somewhat fast. This is basically what D. This is what basically L. Correct है? L हो गया, D हो गया. Now look at here. Now look at here, G value will come L by 2. G value will come here L by 2 and B value will come here H by 2. This is H. This is H. This is H by 2. This is L by 2. Now again apply the same thing, that weight of the body is equal to weight of the fluid displaced. So weight of body will come as 600 into G into pi by 4 D square into L is equal to volume of the fluid displaced, that is the fluid को क्या है, water है, what is the water, yes, 10 to the power 3 into G into pi by 4 D square into H. So from here you will get L by H value. L by H value approximately 1.667 you will get. L by H value you will get 1.667 approximately. Clear hai? Now please listen here carefully. What about now here, what they are asking, that they are asking that for neutral equilibrium, right? What they are asking for neutral equilibrium. So for neutral equilibrium we already know that Bm is equals to Bg. Bm is equals to Bg, then only metacentric height value will come 0 na. So basically condition is what? Bm is equals to Bg. Bm is equals to Bg. Now Bm value will come how much? I by volume of the fluid displaced. I by volume of the fluid. What is I? I is pi by 64, same like previous problem. Pi by 64 d to the power 4 divided by volume of the fluid displaced, pi by 4 d square into h is equal to Bg value will come how much? B and G. Bg means L by 2 minus h by 2, right? Is it? Okay, that I will calculate here. So Bg value will come L by 2 minus h by 2. So this value will come L by 2. H value I can write here like a 1 by 667. So I can say 1 by 1.667. 0.5 minus 0.6. H value is going to be like 0.6 times of L. Clear है? तो easy हो जाएगा हमारे लिए. Now I'll write here 0.6 times of H. So 2 I'll take LCM. So it will come 1 minus H. So 0.4. 0.4 by 2. 0.4. 0.4 by 2. 0.2 I can say. Or 1 by 5 also I can say. L by 5. No problem. L by 5. So Bg value is coming how much? That is L by 5. Okay. Now here d square से ये cancel हो गया, इधर square आ गया. H की जगह पे क्या रख दिए? In place of H I am writing 0.6 times of L. 0.6 times of L रख दिए, right? So you just do it. Basically what we have to find out? We have to find out L by D. So here only L and D is remaining. Just calculate L by D from here. Final answer I am writing that is 0.72 it will come. अरे इतना मैथमेटिक्स कर लोगे यार, आगे पीछे तो करना है. ये इधर बिलो में क्या आ गया? L आ गया. L को इस साइड लेके जाओ, D स्क्वायर इधर लेके जाओ तो L स्क्वायर बाई D स्क्वायर आ जाएगा. हो गया. L स्क्वायर बाई D स्क्वायर अंडर रूट निकाल लो, आ जाएगा आंसर. क्लियर है? So this is basically the answer, right? So I thought everyone got this answer, right? Everyone got this answer. Now before I stop this class, right, I would like to inform something, right? I would like to inform something that in Unacademy, if you want to do the serious preparation either for GATE 2023 or for GATE 2024, then Unacademy is offering two programs basically. One is plus program, right? One is plus program, another one is iconic program, right? In plus program, you will get the help of all the top educators, you will get digital notes, you will get test series. But in case of iconic, you will get some features extra also, like customized doubt clearing session, printed notes, live mentorship. One mentor will be appointed for you and he will do all the things, right? Interactive open house sessions. So there will be some extra opportunities are there to interact with the faculties and other people. Okay, this is these two models. Now if you are a 2024 student, if you are a 2024 student, whether you are preparing for GATE or ESE, then one vision batch is already started. One vision batch is started at 22nd of September. I only started that where all the top faculties are going to teach subjects, and I already started fluid mechanics. Basically I already started around some 6-7 classes are already over. So if you want to join, then join as early as possible, and whatever 5-6 classes are left so that classes you have to cover by watching the recorded lectures. Okay, now if you want to purchase for GATE 2024, then you have to use one code. You have to use one code to get maximum discount, right? To get maximum discount, basically you have to use one code, SHIVAM 101, right? Sir, can I get MTech Aerospace Engineering seat in IIT Kharagpur with a rank below 500 in GATE Mechanical? 100% you will get, beta. Aerospace, very good chances are there. Very, very good. You are general category or any other category? Tejas. Tejas, you are what is your category basically? Shivam 101. So you have to use the code Shivam 101. Clear, hai? Then if you have problem of money currently, then you can choose the EMI option also, that right, you can get a EMI option also. There will be 0% interest, same fees will be applicable. General category, if you are general category Tejas, then also there are very, very good chances to get aerospace in IIT Kharagpur. Very, very good chance. Very, very good chance. Like, if I am not wrong, it's 100%, right? It's very good chance. Why? Because this year the number of vacancies in PSUs are little bit more. So most of the people are going for this PSUs, and even you can get aerospace in IIT Madras also. It may be you can get in IIT Madras also. That is even better than Kharagpur. Correct? Now next one is that this is the fee structure of Plus as well as Iconic. You can see that if you are taking for 1 month event, right? Sorry, 1 year. If you are taking for 1 year, then it will cost you only 3,599, and Iconic will cost you around 4,417. But this is also more. Actually, if you use this code SHIVAM 101, right? 101, then definitely you will get the maximum discount. Even it will be, this cost is going to reduce further, it will reduce, right? And even if you want any help from you, notes and anything you want help, then you have to just type in Telegram that at Shivam Dixit 63. If you type this, you will get to know, like to enter in my channel. In that channel you can ask me either personally or directly, like in the channel itself you can ask if you have any confusion. Okay. Now some people are from GATE 2023, right? Some people are from GATE 2023, so they are worrying about what about me, sir. So for you, one Brahmastra batch is launched. One Brahmastra Plus batch is launched. That is launched just 2 days before. That is at October 1st. Kulkarni sir was started that session basically. Now this is a plus course, right? That is a plus Brahmastra batch is basically plus course. Here all the top faculties are going to be teach, right? All the topmost faculties are going to be teach, right? So you have to attend this class. Now there are 2 Brahmastra batches actually. One is free in YouTube. One batch is basically free in YouTube. Another batch is paid batch, right? So in free, what you will get course complete course. You are going to get subjected by top educators. So whatever faculties are going to teach in Brahmastra, same faculties are going to teach in Brahmastra Plus also. But here daily doubt clearing sessions you will get, daily practice sheets you will get extra, that is DPPs you will get, special by exclusively live classes will be there. Practice and strategy sessions will be taken by the educators separately, right? And study material, you will get complete study material, digital notes basically. Test series you will get complete, right? Then there are 1111 questions that was framed by top educators. So from top educators, Unacademy asked to give some topmost questions which may come in upcoming exam. So that question also you may get from here. Subject workbook also you will get, GATE PYQ book questions you will get, structured schedule classes will be there, there will be no any disturbance. So all these benefits are there if you are taking plus. Only 4 months are remaining, so you can take even 4 months subscription. Even you can take 4 months complete subscription, that is around 19,000 something. And if you use my code SHIVAM101, so currently some discount is going on, so it will come to the 15 to 16,000 rupees only, right? So if you want maximum possible discount, then you have to use this particular code compulsorily, right? Okay. So only 6 months, less than 6 months are remaining. If you want our support, our any support from us, then Iconic Subscription will be better for you, because they will guide you how to study and all. So this is all about today's class. Okay. Tomorrow again we will meet mostly at the same time. I will inform you the timing and all in the group, right? So stay with us and continue your preparation to get top notch time. Thank you very much. Thank you.